Acid-base reactions are a very common reaction and another type of double replacement reaction. You've probably mixed baking soda and vinegar. That's a gas-forming reaction, which is also a type of acid-base reaction. In a gas-forming reaction, one reactant is a base that contains the carbonate ion or the bicarbonate ion. Stop the video and figure out what is the other reactant. And the answer is an acid. In an earlier video, we defined acids and bases, and we looked at properties of acids and bases. So stop the video and review this information. Remember, properties are used to identify substances. This table shows common acids and bases and their strength, that is, whether they're strong or weak. Some of the bases are ionic compounds. Note that the anion is the basic part. Stop the video, take a picture of this table so you can refer to it later. Since acids and bases are often solutions, we can use concentration to quantify the amount of acid or base in the solution. You often know the concentration and molarity and the volume of an acid or base. So for a solution, you can use this equation to calculate moles. Let's do a practice problem involving concentration and volume of a solution. Stop the video and fill in the blank. And the answer is because pH is a way of quantifying the hydrogen ion concentration in the solution. So if you're given the hydrogen ion concentration and want to calculate pH, use this equation. If you're given the pH and want to calculate the H plus concentration, use that equation. Since aqueous solutions contain H plus and OH minus, we can also use pOH. This equation shows how pH and pOH are related. Note that as pH increases, pOH decreases, and vice versa. Let's practice doing a calculation. Stomach acid is a strong acid with a pH of 2.5. Stop the video and answer these questions. And the answers are: stomach acid is hydrochloric acid, a strong acid. pH 2.5 means the solution is acidic. It also means it contains more H plus and less OH minus. We're given pH, so use this equation to calculate H plus concentration. The pH is low, that means pOH must be pretty high. And from the pOH, we calculate the hydroxide ion concentration. Note that for this acidic solution, the H plus concentration is much higher than the OH minus concentration. Sodium hydroxide has many uses. Stop the video and do these calculations. And the answers are: sodium hydroxide is a base. That means it contains less H plus and more OH minus. Sodium hydroxide is an ionic compound. The solubility table tells us it's soluble in water. That means sodium hydroxide associates in the Na plus ions and OH minus ions. A 0.1 molar NaOH solution means the hydroxide ion concentration is 0.1 molar. Now we can use those formulas to calculate pOH, pH, and H plus concentration. Note that the H plus concentration is much smaller than the OH minus concentration. Practice makes perfect, so stop the video and fill in the blanks for pure water and for milk. And the answers are: these calculations tell us that milk is an acid because the pH is less than 7 and H plus is greater than OH minus. Note that as the pH increases, the H plus concentration decreases. Pure water is a neutral solution. A neutral solution has an equal concentration of hydrogen ions and hydroxide ions. Let's take a look at acid-base reactions. An acid-base reaction is a double replacement reaction. So stop the video, determine the products of this reaction, and then balance the equation. And the answers are, and this equation is balanced. Remember, if we can write a net ionic equation, we predict that that reaction occurs. For each substance, identify the compound type, its solubility in water, and what to do in an ionic equation. Here we've identified the compound type and its solubility. In solution, note that the strong acid dissociates into its ions. The soluble ionic compounds break up in ions, but the molecular compound stays as it is. From our molecular equation, here's the ionic equation. The spectator ions are, so our net ionic equation shows that H plus reacts with OH minus to form water. So we predict that HCl will react with NaOH. Life involves give and take. Same is true with acids and bases. Acids that are better givers are strong acids. Bases that are better takers are stronger bases. Another way of looking at it is a strong acid easily donates its proton and dissociates completely into its ions. A weak acid does not easily donate its proton, which means it only partially dissociates into its ions. Also note, if you have the same concentration of a strong acid and weak acid, The strong acid has a higher concentration of H plus ions, therefore the pH will be lower. Let's check out the give and take relation between HCl and water. HCl is the acid and it gives a proton to water. H2O is the base and it takes a proton from HCl, the acid. After HCl gives a proton, Cl- is left. Cl- is called the conjugate base of HCl acid. After H2O takes a proton from HCl acid, H3O+ is left over. H3O+ is called the conjugate acid of the H2O base. Now, chemists are just like everyone else. They like to take shortcuts. So, this equation is the shortcut for the above equation. HCl aqueous is HCl in water. H plus aqueous is the same as H3O+. Here's another way of looking at acid strength. A strong acid is like a big spender. A weak acid is like a cheapskate. We know that an acid reacts with a base, but an acid has to be strong enough to give its proton to a base. A base has to be strong enough to take a proton from an acid. This table lists acids from strongest to weakest. Note that a strong acid has a weak conjugate base. A strong acid wants to get rid of its proton, but its conjugate base doesn't want to take a proton back. A weak acid holds on tightly to its proton, but its conjugate base really wants to take a proton. Let's practice applying what we learned about acids and bases. A colorless liquid is either muriatic acid, the common name for hydrochloric acid, or vinegar. Pause the video and answer this question. And the answer is, do a conductivity test. The strong acid would have a lower pH, but you would need to know the concentration. Sulfuric acid is the acid in car batteries. Stop the video and answer these questions. And the answers are, sulfuric acid is a strong acid. It completely dissociates the ions. That's why we see the H plus and HSO4-. HSO4- is a weak acid. Hardly any HSO4- ions dissociates in the H plus and SO4-2-. For part B, HSO4- is a weak acid in water. You want to find a solvent in which HSO4- is a strong acid. I looked at a more extensive acid-base strength table, and ammonia could work. Let's practice writing net ionic equations. Stop the video and answer this question. And the answer is, and for the net ionic equation, the two weak acids stay as molecules. Sodium phosphate is soluble in water, but the S means that what's being used is a solid. Hopefully you've never had acid indigestion. Stop the video and answer these questions. And the answers are, and for a net ionic equation, magnesium hydroxide is a base. It reacts with an acid to form soluble products. Although tooth enamel is very hard, it dissolves in acid. Stop the video and answer this question. And the answer is, this ion is soluble in water.